Good afternoon, everyone. Thank you for joining us today for the Google information session. We would like to welcome Eden, who is an AU alum. So we're so happy to have Eden back. She's been with us at AU for a long time now, and we're just truly grateful for the time that you've spent to give back to your fellow Eagles. So today, Eden will be focused on speaking on her experience in data analytics and so forth with Google. And before we jump into the presentation, I just want to say a few things. This is a hybrid event, so we do have some students in person as well as online via Zoom. So we ask that when we do transition to Q&A, that our in-person attendees speak loudly so that our virtual viewers can hear. And for our virtual attendees, if you have any questions or need any help troubleshooting on your end, feel free to use the chat feature to do so. Also, I just want to make note that this session will be recorded and will be placed on our AU Career Center YouTube page. But again, the recording will be focused on our presentation here as well as Eden, not necessarily the attendees here in person. But I just want to make that known that this will be recorded. And you can refer back to that recording after the session is complete. And I believe that is all. I will turn the floor back over to Eden. Thank you.
Cool. Thank you so much, Denise. And thank you guys for having me. I'm super excited to be here. I owe AU a great debt to the career that it set me up for. I was able to transition into the workforce very easily. Had great support while I was here from my professors and other students. And I've been able to get a name for myself in the field just through the foundation that I got here, the credential that kind of gave me that level up. So great debt of gratitude to AU. So I'm always looking for ways to give back, and the greatest gift that I ever got was the opportunity to just earn a good wage for myself, coming from kind of a sort of middle of the road income, and being able to ramp up significantly. Had a big impact on my life, opened a lot of doors for me, and so technology has been a big piece of how that's happened for me. And data science in particular, as you know, is huge in demand market. But what I found when I got into the market was that I really only knew a tiny sliver of the things that you can do with AI, with traditional machine learning or like SQL or Python. That's really a very small part of what you actually end up doing. And so I just wanted to spend some time today to give you a little bit of perspective of how Google thinks about AI. We're constantly pushing the bounds of what's possible and thinking through how it impacts society, all the products and services that we create. And a lot of businesses are starting to use that. So part of what Google has done with something called Google Cloud Platform, you've got your Gmail, you've got the phones and Chromebooks and all that. All of those are separate entities of Google. We have something called Google Cloud Platform, which is all browser based, but it's all of our like APIs, tools, and services that Google uses to run Gmail, all of our hardware, all the AI and tech that comes from that, coming from Google Cloud Platform in some way or inspiring it in some way. So you'll see that kind of shining through the presentation, but I just wanted to kind of give you this as something to think about as a way to lean into something more generally called cloud. There's a few big players: Azure, AWS, and Google Cloud. You've probably heard of like S3 buckets and EC2 instances, probably. That's the AWS terms. Google has something very similar. Of course, we're the leaders in AI. So, and all of them are kind of neck and neck, sort of playing off on each other. But you will, if you're focusing on data science, you'll reach a point where it doesn't really make sense for you to be developing everything from scratch like you're probably doing in school right now. You will need to reach out to the cloud to either scale up, scale down in a moment's notice, use an API that's got a pre-trained model. There's a bunch of different scenarios that we'll go through, that you'll start to feel yourself being stretched as you're doing it, the more traditional way that academic institutions typically teach you. But I just want to get a quick feel for the room here. How many are data science or data analytics major of some kind? Cool. Who would fancy themselves more like business? And what else do we have here? Public policy.
PR and marketing.
Marketing,
Economics.
computer science. Okay, so yeah, you're in the zone. Okay. Okay, so I think there'll be something to learn for everybody here. Maybe trying to market these tools at some point, and economists typically tend to need to pick up machine learning tools at some point as well. So, and then business, everything you do is going to be driven by AI. So it's good to have a basic understanding. All right, so a bit about me. So I'm an AI customer engineer in Google Cloud public sector. What does that mean? It's a customer engineer. So it's essentially, we just help other companies run like Google. So other companies may say, how do you tag pictures? How do you scale up when, on Christmas time, your users double and your platform doesn't crash? How do you do that? So we help companies think through all of these use cases. And I bring the AI ML perspective of how the AI can really power whatever their business objective is. And I'm in public sector, which means US only, or North America only. So I work with like Center for Medicaid Services, NIH, FBI, basically any federal institution would be under my purview. So I kind of like the mission aspect that brings as opposed to commercial sector, but everyone's kind of got their own thing they like to do. So today's agenda, we're going to go just a bit about me. I don't want to bore you too much, but just to give you some context. And then we'll go over some of the Google Cloud AI technology, kind of at a high level. Then we'll go into some examples. And I'll go over a few of the most popular tools that you'll probably run into or need at some point in your journey when you're building your own AI stuff. So that's Vision AI, NLP, API, and Document AI. Those are all actually APIs, those three, and they have user interfaces as well. And then we'll do some open discussion. So I'm a data scientist by trade, and that means AI ML specifically, but also natural language processing. And I also do micro web app developments, but that's not so typical of a data scientist. Don't feel like you need to pick up that skill just yet if you don't have it. But I've mostly been in the federal government. Some of those customer relationships I mentioned, NIH, DOE, FDA, IRS, Department of Labor, General Services Administration, VA, NASA, USPS, and USIS there, which is military health. So in my role at Google, as I mentioned, just helping federal agencies figure out how to use AI. I started my journey as an undergrad at Auburn University. Then I set off for Australia in 2009. I did a year there, just working. They kicked me out after my visa expired. Sad, but I had to leave. So I came back here and decided to pursue my master's degree at AU in quantitative, gosh, what was the name of my degree? I forgot now. Quantitative assurance. I forget. It was in the mass stat department. Oh gosh. And after that, I started working at I started working at Booz Allen. I worked at American University while I was getting my degree to get that tuition remission. very great benefit. I worked for Booz Allen for a while and still in the federal market. And then I started working for Google Cloud about a year ago. So for Google Cloud, you've probably learned at some point in your degree that there are any number of essential ingredients. This is what Google, how we kind of capture it here. Typically, you need enough quality data to train the models. And we'll get into cases where when you don't have that, what do you do? Algorithms and tools to build the models. That's one of those that is essential no matter where you get your data from or if you have data or not. Processing power to train and deploy the models. You'll start to see your head bumping into the ceiling when you work for agencies like NASA that have billions and billions and billions of gigabytes of data that span the entire universe, literally, and they need to build their own warehouse or infrastructures just to be able to train a model. And then you need your design and development teams, and that's where you guys come in. There's two basic ways that you can deploy machine learning. The build it yourself, which is probably where, if you're a data science or computer science major, that's where you've spent most of your time. Not a lot of degree programs get into the cloud, or this right side here, which is where you start procuring ML services. And they're not super expensive. But in the build it yourself, that's where you're getting your Python libraries, installing something, training your own models. You could use PyTorch, TensorFlow, R. There's a bunch of different free softwares you can actually do that. But you also run into limitations here on quality and volume of data to really make a good model here. When you procure ML services, this requires less human capital. So you can typically, a lot of companies go this way if they just can't afford a team of 10 data scientists and they just need to speed their development to create their application. Because it helps you cut a lot of corners. So I'm sure if you've built a machine learning model, you know, it might take you a month to actually write the code, test it, you know, get the data, clean the data, all of that. There's shortcuts on all of those areas when you start to procure services. And then there's also cloud on device platforms that have ready to go AI products. So we'll get into some of those, the vision, language, recommendations. You see here in this picture, that's probably something reminiscent that you'd see on your phone where you take a picture of something and it tells you this is a cat, this is a dog, this is a tomato. Those are what's called pre-trained algorithms. And so it helps you. You can imagine, I talked to a student a while ago that was working on a project for a blind person. So if you can imagine like maybe a camera on their glasses or on their lapel that just tells them what's in front of them. So if you're blind and you're walking through, you'd want to know any obstacles that are in your way. Step up. Am I going to run into a chair? Am I going to run into a person? Is there a bird that's going to fly and hit me? So it needs to be fast, and you don't want to waste your time trying to get training data for chairs and animals and the abundantly infinite list of things that you want to let somebody know. If it's a rug and it's a slightly lifted rug, you might say, lift your leg up a little bit, or there's a tiny stair, or there's a big stair, you need to lift your leg higher, something like that. So there are pre-trained algorithms that can limit your work on gathering that training data by like half or even 80%. Because companies like Google or AWS have spent a ton of money procuring a ton of images. How many images do you think are on Google? People have uploaded them and have them in there for training data. Like millions.
Millions.
I don't know the exact, but a heck of a lot, right? A lot more than any one person or one institution could possibly maintain. So we leverage that, paid a whole bunch of humans to label a whole bunch of images, and we have services like this. There are also two types of building blocks. I mentioned these pre-trained models, and we'll get into some examples of that in a little bit. But they're for common use cases. So we'll get into some examples here where your idea or your product or your concept or your use case is so unique and so individualized that you have to build something custom. But you may be able to capture like 80% of what you're trying to do with a pre-trained model. So coupling that and finding that balance to try and speed your time to market and just try and get the best quality tools possible is really to your benefit. Then you've got your custom models. And so that's where you need to really try to pay attention. What is it that I really want to spend my time on for my product or my company to really differentiate it? So at a high level, so Google just built something called Vertex AI a couple of years ago. And we tried to just put everything AI ML under one roof, and they called it Vertex AI. So that's everything from like vision. We've got just like a pre-trained model that does some of that picture tagging, like I talked about. Auto ML, which lets you train your own model. All you do is give it your data, and you say go train. Well, it's a labeled image data, and you just say go train it, and it actually goes through 200 some odd neural architectures. It does the search for you, figure out what algorithm is the best, trains it, gives you the best model. That can happen in like 10 to like 30 hours of training time. Some like NASA probably spends like a week or two training theirs. But for most use cases, you can get things done in a few, like a day of training. So you can imagine how that just scales down your work time from like weeks to hours. Video intelligence. This is a cool one that we've seen used in security a lot. I had a use case with LA County Public Library a while ago that was trying to figure out how they can do simple stuff like just counting the number of people that are coming in the door. They also want to know what type of people are coming in the door. Our APIs can differentiate between the elderly, middle-aged, and kids. And so you can imagine how that would be beneficial for a library for planning events and services for the library. If 80% of the population is elderly, they probably shouldn't spend much time focusing on events for kids. They'd be much more better suited trying to schedule things around the elderly population. Language, we've got translation for documents, not just voice on your phone. We can actually translate full documents and maintain the structure of the document, like a PowerPoint. You upload a PowerPoint to say, I want this in Chinese, click Chinese, you've got your whole document now done in Chinese. So it's important for the federal government in terms of just making it all the tools accessible to as many people as possible. You can imagine there's got a large immigrant population, and so when they come in, they need services from the government. They have to be able to read that stuff that's on their website, right? So trying to make everything accessible is really important. Natural language as well, but natural language processing I touched on earlier, and auto ML natural language too. So it lets you train your own model with Google's best in class natural language processing, which is not if you're using an NLTK or any kind of Python library, you are about 5 years behind. So catch up, use something called BERT, which Google actually gives out for free. And then if you want the best of the best, the best, the best, use Google services. By the way, I'm not trying to sell this. This is just one service that's out there. You ideally do your homework on the other two big cloud providers to see what they have and just measure which one is the best for your specific use case. Conversation. This is like where chatbots and things come into play. So dialogue flow is that like chatbot back and forth between the customer. Speech to text would be part of that. So a person calls in, all we know is the words that we're saying. We can actually process that, and so we turn that audio into text. So that's a critical step, and it has to be really good quality. And that's why using a cloud service is really beneficial, because you can imagine how many different ways a person can speak English. If you have an accent, if you've got like a mixed accent, if you have a speech impediment, that's where you need just so much training data that it's really impossible for you to make your own. So it's really a time saver to use something like this. Text to speech the other way around, and then speaker identification. So that's where like your home Nest or Alexa or whatever device comes in, and she asks you, hey, please identify yourself. This is the first time that you're using the product. And if you have multiple people in the household, it should be able to identify who's speaking. So if I say, hey, play my favorite playlist, and it knows it's me speaking and not my 4-year-old son, it's not going to play some Big Bird Sesame Street thing. It's going to play something that I like. And then when we get into structured data, there's all kinds of best in class automated tools you can use just for like your structured, like tabular type data sets. Tabnet is kind of the growing in demand one. That auto ML tables, it does the same thing like I talked about, runs it through the neural architecture search and gives you back the best model. So that is absolutely no code. It's a button click away. I kind of turned my nose up to that at first, but it's really, really, really good quality models. Time series, we do fleet routing as well, and then forecasting. So as GCP users start to kind of get in, you'll see these different personas here. There's data engineering, data analysts, which have BigQuery, that's like SQL. You can actually do machine learning in SQL too. Model development, that's where the data scientists live in Vertex AI, and probably BigQuery too. And the ML engineering, so that'd be where you deploy your models, get them out to whatever device you're trying to deploy to. And then your insights and activations, that's Vertex AI too. You have to manage that whole concept of like, you know, you have to deploy the model and then you kind of monitor it, make sure it's still working a year from now, and deploy an updated version if necessary. So that's all managed in Vertex AI. That's why you see it in 3 of those. And then Looker, that's just like a data visualization tool like Power BI or like Tableau. And then we've got something called App Engine too, and that's what we use for just standing up applications quickly. That has been, this is my favorite. I love App Engine. I was able to deploy a couple of applications and 2 lines of code, I'm not kidding. Like pip install, cloud run, enter, we've got an application. They manage all the infrastructure for you. If I have 2 users today and 1 million tomorrow, it scales up automatically for me and just lets me know. Hey, you've had a big influx, we've already taken care of that for you. So that's, you don't have to worry about all of that, which makes using the cloud just a lot easier to adopt. Obviously, there's a bunch of opportunities here. I'm over here in public sector. As you can imagine, pretty much anything could use this, and we have customers in all of these areas. So when you're looking for jobs, this is a great, any kind of certification in Google Cloud Services or AWS or Azure, they're all pretty much the same thing. It's just you have to learn the names of all the products. But having at least one of those on your resume before you graduate is going to set you up to work in any of these industries. So, so it's a great credential to have, and it's easy to learn once you know one of them. So just pick whatever you're most comfortable with right now. Developers, myself included, tends to lean towards GCP because it's a little bit easier. There's less lines of code. They've kind of the sales and marketing and UI applications just make it faster to adopt, but that's personal choice. So yeah, all right, so we get into the fun stuff here, some examples. So we're working with the Navy to identify rust on ships like you see here. They've got a huge fleet of vessels, and they wanted to just send her on a drone that just flies around their shipyards and says, hey, ship 46512 has got rust on the bow, which is high risk, and sends back an email to somebody that says, come check this ship. You imagine how hard it is to actually maintain a fleet as large as the Navy has. Before they were just having humans do that, it was taking too much time, and so they were trying to figure out some creative way to just kind of get an indication on how much work needs to be done. You know, how many engineers do we need to hire to actually fix this issue? This is kind of a cool one that we did in Thailand. There was a shortage of doctors in Thailand, and they asked Google to try to help to see if we could get ahead of something called diabetic retinopathy, which is quite common. It is easy to diagnose, but if you don't have a healthcare practitioner at all in your village, it becomes impossible to diagnose quite quickly. So assuming that they do have the technology to get a scan like this, we were able to give them some software to diagnose this early, because if you wait too late, you can become blind. If you catch it early enough, it is treatable. So you can imagine if somebody has a 2-day hike to get to a facility where they need to get action on this, they're only going to go if it's like almost for sure that they have the diagnosis, right? And they don't want to go all the way over there to an urban area to get treatment. If it's, you know, oh, maybe it's, I'm having vision problems, but I don't know what. We got a whole team actually of people who work on these high impact areas here that are kind of more about social impact than anything else. We also, early COVID, used AI to model vaccine hesitancy, just to try and help the federal government try and inform shift in vaccination distribution paradigms, combine administrative vaccine data, HPI, and kind of just overall sentiment, so they could give them some kind of visualization like this, so they could maybe send outreach teams to just try and educate people on why they need vaccines, what the benefit is, put more, you know, pop-up tents to get the vaccines, what have you.
Eden,
All kinds of cool stuff.
are you comfortable coming in over just a little bit for the camera? Just a little, like right there, that's perfect. If you're comfortable with that.
Yeah.
Thank you.
There's also a lot that we can do with something called Google Earth Engine, which we've got different satellite imagery that's captured that can do things like early fire detection, tracking fire state. So how is it spreading? Where do we need to send services? And then predicting fire spread. So we have aerial image and we see that there's a wind shift and that the fire is going to go north rather than south. We can inform the rescue team where to send their troops. A bunch of other applications here, kind of across different health sectors, health, medical imaging, diagnostics, chatbots for mental health, agriculture, predicting crop yields, site-specific agriculture. So trying to understand how much corn is grown in a certain area versus, grass for feeding livestock, democracy and governance, detecting tax evasion. I did that for a little while. Boring and soul sucking, but someone's got to do it. Tracking media reports of violence against women, and then environment, like habit monitoring, spotting illegal fishing catches. I was working with I had a colleague who just finished a use case with let's see, what are they called? They're the rescue team for any kind of sea or ocean. I forget the name, but they were trying to understand on drones, like if they could understand if a boat had capsized or if there was a swimmer that needed assistance out in the ocean. and ping back the lat long coordinates to route rescue services. All right, so we're getting into some of the more specific products here. The Vision API, you can actually try this yourself, but it can do anything from classifying content. This is the Navy use case, Rust versus not Rust. Detecting objects to retrieve coordinates, like finding where's the basketball on the page. OCR, it's not your grandmother's OCR. This is really good quality. OCR can actually understand cursive, handwritten, which we'll look at in just a sec. Grab that text off the page and then finish your business analytics off of that. Detecting brands, you can imagine on like mail or like any kind of documents might want to pull off that logo and figure out what company it is. Detecting faces and emotions. So what is he feeling right now? He or she feeling, and then detecting popular places and landmarks, which we'll see also a demonstration of in a second. And then finding similar images on the web. So I want 4 images similar to this one. If you want to, I have this cat and I want to see, maybe I'm a breeder and I want to know other breeders who might have this specific cross of a cat that I'm, selling. Moderate explicit content. You'll see that kind of coming up in YouTube Kids. So it'll filter out anything that's explicit so that a child never has to see that. And then identifying image properties, colors, etc. I'll show you a use case with that in a second, but the National Gallery of Art is interested in this particular component to try and classify images into different types of moods. So something that's more like cool colored. People want to search art based on, emotions, feelings. So colors have a lot to do with that, right? So if we can pull that content out for them and tell them what the dominant color is in an image, it helps them to kind of route people. You can see that coming through on like shopping applications, like what is one? I forget what it was. I was shopping on a website recently that had just really remarkable. I chose on like a lamp or something, and it gave me such good recommendations that like match the color and match the shape and match like everything I was looking for in this one lamp, or a baby crib and all the specific features. And you can just tell it had really robust AI behind it, to give not just like a random, rules-based type of recommendation, but something that was really rich. Getting hints for best image cropping. That's probably good for like something really at scale, like people are uploading pictures and you want to organize it a bit. Extract printed and handwritten text, we'll see that in a bit. And then everything here that we talked about is actually available in video as well. So you can imagine how that could be useful for self-driving cars. Trying to understand if you're on the highway and there's a plastic bag that's running along the highway, you want to know what that is to know if you need to stop at 60 miles an hour, or if you can just run over it. So that type of image recognition becomes life and death scenario very quickly. How are we doing on time, Bernie?
So we're at 1:36, and we want also leave time for a little for Q&A. So, yeah.
All right, so we talked about the pre-trained models here. So with natural language processing, you can do what's called entity extraction. So how many of you here are familiar with bag of words? Yeah, just one. Okay, so with understanding natural language, one of the biggest barriers that we've just broken through in the last 3 years, just as a research community, is understanding context clues from language. So think about a word like bank. We could think of at least a few different ways to use the word bank, right? Bank of America, that's a proper noun. I'm going to go to my bank. That's, a banking institution, not necessarily Bank of America. I'm gonna go to the bank of a river. And to understand what type of use of the word bank, you need to understand the context of the surrounding words, right? So bank would be, it's basically like nouns that the entity extractor is trying to pick up. It becomes really useful for like topic modeling. To just try and get all the main words that are being used in a body of text. And then try to understand what that is. So it might pick out American University as an entity, and then be able to relate that back to the American University website, and then tag it back to it's located in Washington, DC, and so many students it has. So it ends up informing a lot more kind of down the road. So it's more than just nouns, it's a little bit more robust than that. Detecting sentiment. So this could be anything from like happy versus sad. You can actually train your own model to understand something that's really important to your user base. So you can think about like a mental health app that might want to actually diagnose some kind of a or predict a type of diagnosis based on someone's language. So schizophrenia or like manic depressive based on like journal entries or telehealth appointments with their service provider or a nurse, maybe to try and take action quicker rather than later. Veterans maybe that are coming back that need mental health services right away because it is a life and death suicide type of situation. And to what extent, how manic depressive, that you can get like a scale off of that as well, which is pretty useful. Analyzing syntax as well here is really important, and then classifying content. So that might be like a document that's coming in, or you'd say like journal entries, bucketing them into like, what's the possible age of this person who wrote this review? How should we respond to them? This particular academic paper, what's the academic sort of bucket that we would put it in? Kind of thing. So this is conceptually what it looks like here. You can see like the blue words here are entities, and it's grabbing off. It'll tag it for you, so it'll say like GlaxoSmithKline PLC. It looks like a type of organization, and it is like a business name. It actually grabbed a Wikipedia article for you there. The salience is how important that word is in this paragraph. That's where I mentioned that this entity recognition becomes really important with topic modeling that is famously hard to tackle. And then London, and try and understand. See, we've got like London Stock Exchange is different than just the place London. London Stock Exchange might be located in London, but it was able to understand that these three words used together are one thing as an entity. This has been a really challenging problem to solve, but finally been able to do it. You see here we get the score of like how likely it is that, or how good is our guess, and then its magnitude. So how important is it in that paragraph? All right, so document AI. This is really important for federal government because you imagine a lot of handwritten forms or PDFs get sent in to the federal government, and they need to be processed. That's why you have like huge wait times for things, you know. So the DMV is so painful. Immigration services are extremely painful. They have to wait a really long time for them to process all your documents. Department of State was having a big problem with this, and when the epidemic hit, they had a lot of expatriates that wanted to come back to the United States, like right when COVID happened, but they had to submit paperwork for that, right? Of course, to get money and to get flights back and all of that. So there was this huge rise in, you know, maybe they might have one or two a month. Now they've got 50,000 people trying to get it. So we actually help them to just try and process those documents and get them through those initial phases of just grabbing off whatever the information is off of that, so they could try to just even like automatically approve some of those cases where the humans can spend their time on the harder cases that really required more thought. So basically, your first case is read it. So that's your optical character recognition, or OCR for short. And then understanding it. So trying to understand even like what form is this? Imagine an agency that has just like one place where all the documents are coming in. The first step might be, tell me which document has been submitted, then go do the appropriate steps based off of that. And then make it useful. So that's where you start writing it into a database, and then your workflows get kicked off from there. Or visualizations, whatever. So you've got this huge stack of documents. What happens next? You need someone to actually scan that, put it in somewhere, or the user uploads it to a user interface. Doc.ai pre-processes it, splits off all the information, classifies the document, extracts the key information, and then try and standardizes, and in some cases enriches the data. So it might try to understand perhaps metadata based off of that. So maybe it's you get the employee's name, and then that works for Department of State. And then you reach back to the database to get like what was their hire date, how long have they been deployed, to try and give more information to make that business decision happen. And then as needed, human review. So that's where we just try and limit like 50,000 documents down to like 500. So try and let AI take care of the really easy stuff. That's like, check, this is an easy one. And then if there's something that's like someone scribbled in the margins, or the handwriting is too tiny, it couldn't pick it up, or they were missing information, missing fields, something like that, that a human needs to take some action on, or a hard case, that's where you want your humans spending your time, not on all these mundane kind of processing steps. This is like real life AI. So you can do this with like something as easy as just receipts. Almost every company in the world has to process receipts. Companies go, somebody goes on a plane trip, they have to submit their receipt to get reimbursed for that trip, right? It happens with almost every company. Google's built AI to understand receipts. So it's very good at understanding, for example, which of these numbers is the total here, and which of these is like the items that I need to pull off, and what's just like garbage that I can throw away, like this stuff down here. What's the name of the company here? Is it Angelina Paris? Is it Angelina Rivoli? It'll try and understand that as well. Classify it, make some prediction off of that. That's what we see here. It's picking up business name here, the location, and the total. So we've pre-trained algorithms to do all this for you. You just give your receipts, and you don't have to spend months creating your own parser to do this. Anybody who's actually tried to do this, you would breathe a sigh of relief. Yes, I have to save myself like 2 months of work. You get out something like this. The line items, the total amounts, and then you get a JSON response, and you can do the fun stuff like approves the expense report automatically or whatever. Google takes the extra step to link into Google Maps and say, oh, Angelina Paris, based on that address, awesome. Let me tell you, like, if somebody's trying to just submit an expense and get back money, but it's like not actually a valid expense for that person, you could do some kind of quality assurance check here, like, okay, they went on a business trip, but they stopped by the pet store to get fish food. Oh, should we reimburse them for that? Maybe not. So you can understand like the business, what type of business is it? Is it an appropriate expense for an employee to be trying to get expensed on? And this human in the loop, we actually have an interface that looks like this that just sends a human an email instead of having to build your own application for it. Just send a human an email saying you've got something to review, come check it out. They make changes in the user interface. This is important because they don't need to be technical at all at first. Everything is in the UI. So before like a data scientist or somebody technical would have to build something for this person to actually look at. And Google's taking care of that for you too. So this is kind of the big picture, capture, process, store, analyze, and use, kind of similar to what we did. Sort of in the loop here. Eventually you get into dumping data into like a SQL service like BigQuery or anything like that, MySQL, and then some kind of business intelligence tool like Booker or Power BI. Who's actually using this right now? United States Customs and Border Protection, the IRS, Department of State, as I mentioned, and a bunch of others. You can actually see this in action here. You were talking to a government facility that was trying to read letters like this from that Lincoln wrote, because it was really hard for, they had a bunch of documents that they wanted to pull the text off of so that they could search it. But the handwriting was pretty small and cursive-y. So we actually, I'll show you what this looks like for like something easy. You can see a document here. It's just like a nice like text, and it picks off the text like pretty easily. These cases are extremely high accuracy, but you'll see where you run into the limitation of AI when you start to look at like this cursive text, which is where the human in the loop comes into play here. So I'll just upload that letter that we just looked at. We'll see that the quality is okay, but really what we're trying to do is just help the human do their job faster. We can say, I'll take care of like 90% of this, but you'll have to do the other 10%. And if they've got 10,000 documents to transcribe, you just limited their time by like 90%. So you can see here. So that actually, okay, like Dear Madam, that looks like pretty real. Paris, February 22nd, 1787. You see here is where it gets kind of loopy. I, Hacker Sledge, the honor of your letter of January age and of the par yours. So you see here it starts getting a little bit wonky. They can't quite make out every single letter. If a human can't read it, typically this can't read it either. But a human who's a subject matter expert on Lincoln might be able to guess with much better accuracy than this. Well, like, okay, this letter was written around this time. That would have been like this event might have been going on at that time, and this is probably the word that he meant. So I can replace it. So if you're going to spend somebody who's got 40 years of experience as a subject matter expert on handwritten language from Jefferson, they're probably very expensive, and you don't want them spending hours and hours and hours on the easy stuff that a machine can do. Spend your time on the 15 words here that we don't actually know.
And we're at the 10-minute mark.
10-minute mark. All right. And then for like vision AI, so this is a painting of Van Gogh. National Gallery of Art has asked us to automate some of the tagging for their images. I was showing you to try and get like some metadata off of the picture, just to, maybe they want to do like an application and have people search their content easier. So I was actually able to understand that this painting is hanging in the National Gallery of Art, linked it back to the location. What type of objects do we see here? Person, you can see it's kind of off here on animal. I'm not sure why I did that. But you can see where you kind of hit the bounds of what's possible at some point, just where thresholding is really important. You might say, I don't want to take anything less than 70% or 60%. And he's wearing clothing. What are some of the labels we get off of there? cheek, chin, some kind of hairstyle. We can tell it's a painting. We can tell that it's a watercolor painting with 74%. You can imagine how this could be useful if there's a whole bunch of different pictures, like cars and stuff like that. Let's try to understand what exactly is this. And these are the dominant colors that it was able to pick out here. Then we had safe search on here, so it's very likely to be racy and very likely to be violent. So yeah, this is where it kind of helps sort of build that scale. I think that was pretty much the end here. Open discussion, cool, perfect time. 10 minutes. All right, I just threw a lot at you. I'm sorry if that was like too bombarding. I had to give you just a good sense of where your career growth might go and where you might start to need cloud at any time, or where you might want to advise your employers on where you want to spend just a little bit of extra money to save time. If you're going to pay a developer $150,000 a year, wasting a month is more expensive than just spending like 5 or 6 cents per page on something that's already built for it. So yeah, it's just about does it. We'll open up the room for discussion. I think we've got chat. We'll start in the room here. You guys want to talk about? I can tap dance for a little bit. Give y'all an opportunity first. What do you guess as far as like salary trajectory? What are you guys thinking is kind of in your mind is what's the possible range here that you should be looking for your first job? When you get to a negotiating table, what should you be asking to get paid if you're going to be a data scientist?
90.
90? Yeah.
I think over 90 or
Over 90? Good. Lance? That sound good? 90 is probably the bottom. So that's what I've been seeing students from American University getting offered with master's degrees in some type of data science role at like mid-level companies. So it'll go up from there in private sector, big companies like this. Really important when you're at the negotiating table to really do your research on like the specific type of languages, you know. Glassdoor is not super helpful in that respect. I like to use something called PayScale. PayScale does a really good job. It asks you every single computing language that you know. Gives like give a really good description of what your skills are, exact years of experience. It's much more fine grained. With the list of stuff that I put in, there's only 20 people that actually matched my exact career structure, and the expected salary was a lot higher than what it was in Glassdoor, because the Glassdoor is like they don't narrow their niches well enough to really give you a good perspective on what to offer. And do not fall into the trap of thinking, oh well, you know, the company will just offer me whatever is like fair. I'm sure they're a good company, and I'll just take whatever the initial offer is. Never, ever, ever, ever do that in the data science area specifically, because gain is the same as if you're going to get a car. That first number that you get is the start of the negotiation. That's the base that you're looking for. So you need to do your research. That's like way under what your research is telling you. Ask for that higher price. That's typically they'll go at least like $20,000 or $30,000 below what you actually should be getting paid. So I made that mistake and I was kicking myself 4 years later when I was asking my colleagues what they brought in at the same company, same background, and yeah, it was like $20,000 under that. And I was very naive. I didn't do my research, and yeah, I probably lost like $50,000, $60,000 for that time. So
We have a couple of questions in the chat, so we'll start there. If we're interested in working in data analytics, in AI or NLP, what kinds of things do we absolutely need to demonstrate on our resumes?
Great question. So as far as computing languages go, you definitely need to have Python on there. At least. If you've got MATLAB or R, those are very infrequently used in the real world because they're very much academic. So although it doesn't hurt to have those, and if you did that in your class, then put them on there. But it is worth, if you haven't had a class that used Python, that's a must. Probably 90% of the work that I've done has been in Python. Almost every single API that I use has a Python SDK. You will never, ever see one in MATLAB or R. I've never seen one. I don't think they exist. So that'd be first. And then as far as experience, I say experience because I made a mistake early on of thinking of experience as some work that I got hired to do and was paid for. That is, do not limit yourself to those bounds. Any project that you did with your friend on the weekends, building a video game or just like playing around with like some open source technology for your grandmother, that is experience. You worked through a use case, you had a problem set, you solved something, you can talk about that experience to highlight what they really want to know is, if I hire you, can you build something with very little direction from me? How dependent are you going to be? And if that's looking like I've never touched the command line at all, that's going to make it a much harder decision for that employer to make. If the person sitting to your right has all these really cool projects that they just did on a weekend, they never got hired to do anything. But if you talk very intelligently through each one of those experiences. I talked to a guy the other day, he's an undergraduate student at Rice University. And in high school, he helped a team develop a robot that saved the puppy from a well. And he may have his contribution may have been limited on that, but he was able to talk through the use case, say what computer languages were used, and had a cool story to tell. So that's really what employers want to hear, is how intelligently you can think through the business application. What were some of the hurdles that you faced? How did you get around those? What were some of the realistic limitations that you ran into? It's perfectly fine to say, we built a model, but the accuracy wasn't great because we didn't have any funds because we were students and we couldn't buy enough data to actually inform a good model or procure cloud services. That's the real stuff you're going to run into on the job that you're going to get with that type of raw experience. So if you have internships and even unpaid internships or whatever, that's great. But I highly recommend doing projects on your own outside where you can be your own boss, get on the command line, code something up, experience stuff for real, because that's going to help when you get into the coding interview and you actually have to think through a solution, type it out yourself. If you've only been doing, at least in my experience, the homework and stuff that I did in class at AU is not enough for me to really feel confident. Taking an idea from scratch, not a ready script that you saw in a lecture and you just had to change a few things for your homework assignment. That is a crutch that is really to your detriment. Start off with a problem statement. I want to make some type of GoPro camera that I want my grandmother to wear so that she doesn't trip over the curb when she walks out to her car every day. And I want to recognize that for her. Put something in her earbud and say, "Hey, grandma, there's step down, slow down." That would be for me as an employer, I'd be "Oh my gosh, that's awesome. What'd you learn? What software did you use? What were some of the challenges that you faced?" if I can talk through that with a candidate. That compared to like, okay, I interned for my senator and made copies and got people copies for a semester. I'm gonna trust that person to actually put in the hard work to code something more so than a really big name, but you actually didn't really do anything that's gonna be similar to the work that you'll be doing at my company.
All right, great.
I just wanted to.
No, go-
I could
go
step
ahead.
out
Sure,
real
sure,
quick,
sure.
but I just want to say thank you so much for the presentation and information. I just don't want to interrupt.
Oh, we appreciate it. Thank you. Um. So the next question, I'm an international student and this industry is quite hot right now. Is there any way I can make myself stand out more?
International student, okay, so I'm
Yeah.
hearing visa.
Yes.
That is always a challenge, always. So in terms of, just trying to get the most bang for your buck, if you're an international student, it is the visa process can be quite taxing on a company. It's, it can be expensive, you need lawyers. And the time, to process it is, can be painful. I've seen even like mid-sized companies give up because the process is so very painful. So if you're on OPT, that's a different situation. I mean, Biden, God bless him, gave data scientists 30 years of OPT instead of just the traditional amount. So you've got a little bit of leeway there. But if you don't have an OPT situation, putting your eggs into more baskets that are larger companies that will have the resources and the law departments to actually process your visa and be willing to do that. Would probably be where I would spend my time. And then getting those certifications, like I mentioned early, one of my colleagues, she is from India. She's on that H-1B visa. And her first job was at AWS, the first job out of college. So what she did was, she just tapped her LinkedIn profile with as many keywords in that industry as she could, just trying to get that boost up. That algorithm that is like catchy on, like recruiters love to search on LinkedIn. And so you'll get pushed up the algorithms if you do that. Have at least 500 connections on your LinkedIn profile. If you leave, you don't look for jobs. Jobs come to you. If you're in a high demand market, you do not go looking for jobs. They will come to you. So unless you want to work for like really big company like Google, then they're probably not fun for you. Because they have like 1 million applicants a year. But in my experience, it's been worth it to decide on like 3 or 4 companies that you are really passionate about working for, and just do your darndest to study for those 4 companies, tailor your resume specifically to each one of those. Make sure all the keywords on it are relevant to that company. So that like when you get into the interview, you can talk about things like, hey, I really love your values. And I love how you've, reached out to local communities and you can really talk personally. I know for sure that a candidate gets into an interview with me and they've had 10 interviews that week and they don't even know what interview they're sitting. I know because they don't say anything related to my company. They can say, okay, what do I want you if you don't really want to work for me? Are you going to stay at my company long enough for me to train you and get use out of you? I'm investing in you as a person as much as you're investing in me. So I want to make sure it's, it's like a feeding game. You don't want to get with somebody who's got kind of the people that are like, they're thinking you're all the same, right? And it doesn't matter, companies want to feel like you know them, that they're special to you, that you know them. And so that's what's going to get you to be competitive enough. Because then they'll want to put the work into like waiting for your visa to go through. They actually have to like write justification to the Department of Labor that there were no candidates like you, and I need this person because there's nobody else in the United States that I could possibly get to meet that need. That's just how the government works. So, you really need to make yourself look special, and in high demand areas like that, like this, it's much easier. But yeah, I hope that answers your question.
Great. How important is it to have a connection to get a job at Google? Would you say
It's-
that's important to have?
So it helps with, I would say, more with the getting through the interview process than it does to actually get a call back from a recruiter. A Googler can tell you a lot more details about what's out there on the internet for how to actually be successful in negotiations, getting through the interviews, answering questions, and how to answer those questions successfully. But as far as in my experience, just having a referral from a Googler doesn't necessarily get you through the that initial screening phase of just getting that call back from that recruiter. Google gets the chances of getting that call back are less than 1%. So the competition is fierce, and as much as you can kind of position yourself to be like as fit in kind of like a niche area as possible, the better. The recruiter at Google told me that they're really interested in my public sector experience because I applied to a public sector position. So just that little thing kind of made me a little bit more unique. And I got a call back in under 30 minutes. But I didn't get a call back at all for a position that was not in public sector. So, yeah.
We're doing pretty good. Yeah. Let's see here. So what are the technical interviews like? I'm combining two questions here. What are some of the most important tips or strategies for interviewing for data science roles?
And Google, I'm assuming, or just, okay. So Google's a different beast. It is, their interviewing style is way different than just about anywhere else. First thing I'll highlight is the time it takes to actually prep for them. I spent weeks studying, months studying for my Google interview. Because I didn't want to take it lightly. I knew that it was a really big deal to get in there, to even get the call back in the first place. And I didn't want to blow that shot. So you may be excited and think like, tell the recruiter I want to interview right away. Don't do that. Give yourself time, give yourself weeks, as much time as the recruiter will give you, or as much time as you have to study. Start studying now. I think in total, I probably studied for like 5 months. Because I knew as soon as that job posted, and I was going to be ready to apply. So updating my resume, watching a crazy amount of YouTube videos on how to be successful, what types of questions to ask, and then more importantly, the framework to answer those. So there's role-related knowledge to be specific to any kind of, like for a data scientist, machine learning, that's all about machine learning. So they get questions like, can you explain how a neural network works to me? But then on the, there's a leadership and Googliness interview, and that's actually happening from the very first time you speak to the recruiter until it ends. They're basically trying to see what type of person you are. Are you like a culture fit, basically? So that's being assessed. Every email that you send, every phone call that you have with anybody that is always being assessed. So, and then there's the general cognitive ability interview, and that is where you're given some type of scenario, and you're asked to think through like how you would solve that. So, for example, you might get something like the customer wants advice on where to stand up their next facility. What would you tell them? So you get a blanket statement like that. So they're trying to see what type of questions are you going to ask, or are you just going to fling off an answer and not think about it, and just start answering it. Never ever do that. What people wants you to do, slow down, take a deep breath and say, what do I want to know? For example, what industry is this customer in? Can you tell me what the customer name is? If not, can you tell me, how many facilities they have already, where their customers located? Are they a global institution? Are they, just located in one specific country? Are they looking to expand? How many employees do they have? How many customers do they have in the areas where they don't have a facility? Or do they have data to support that decision-making process? What type of budget do they have? We need to do all those kind of like, I'm not an expert in that area at all, but like common sense, trying to think through. If I was in that person's shoes, what are the things that I would think about? Financial, people, probably wouldn't want to put a facility in like a major hurricane zone or a tornado area. You don't know what you're going to get destroyed, right? So, and once you start to like really think about it, and put that framework around it, you can answer any question, and any subject. I mean, and it's really about asking the right questions, to just try and make the most informed decision as possible. It's not about how much you know about, we're gonna put a facility or whatever the specific use case is. That's not really the point. You're just trying to see how much humility you have and how thoughtful you are about trying to use data to answer your problem, answer the solution.
Want to open the floor to any in-person questions. We have one more online, but just want to give our in-person attendees an opportunity.
So if you were to go back to college as a student, what would you do differently, like career-wise to advance?
I would spend a lot more time teaching myself some of the more cutting edge tools, and some of the open source libraries that my classes just weren't hitting on. There's only so many classes you can take. There's always a bunch of electives, and sometimes they don't have slots in them, but you might know that they're in high demand. Don't let that stop you. I don't care if I have to go to sleep at 2 a.m. every night. I'm going to take an extra course on Udemy or Coursera, just to try and get myself familiar with that concept, whatever it may be, natural language processing or cloud technologies. I do wish I would have known more about cloud before I did the industry, because now it's becoming a must-have. And your curriculum is there's only so much time, there's only so many classes that you can take and are being offered. Don't let that be your bounds of what you consider as far as what you can learn. There are so many other extremely cheap resources to educate yourself. Top ones, Udemy, udemy.com, and then of course you can get courses for like $10 on there, and they're a lot of times like very rich content. And you can put those on your resume. Don't just, again, the price that you pay for like an actual institution like American University is great. That'll open a lot of doors for you. But you can also stack up those skill areas with other resources like Coursera and Udemy, or even just like Kaggle, submitting, being on Kaggle competitions. Anything that you can say, I know about that, is fine. You'll get questions like this. Like, I had an interview internally at Booz Allen, and they were saying, hey, we need somebody on this project, and I thought it was a cool project. I thought, oh, but it's Python, and I only took like one class on it a long time ago, and the entry level, I don't know it that well. And so I told the hiring manager that, I said, I see it's Python, I don't know it that well. I said, don't worry about it, I know you're smart, you'll get it, let's go. That's how it is in a high demand area. They're not looking for experts. They know that if you know one language, you can pick up another. If you've proven yourself as somebody who just like generally has high aptitude, you'll be trusted to get some really cool projects to do some much more fun. So yeah, it's worth it to at least get that one, what's called like object-oriented programming. So I only knew SAS when I was here, that was the only programming language, like O and R. SAS is not object-oriented, so I had a huge learning gap going over to Python, but now that I know Python, I can pick up JavaScript, Node.js, like there's a bunch of other very similar languages, and they're very easy to pick up once you have that foundation.
Any others?
Thank you for the information on everything. I would like to ask, are there opportunities for internship at Google, and also for someone just considering to data analytics, what are the chances of getting a job in Google?
The chances, less than 1% of 1% are actually getting a job at Google, so I think, they're extremely competitive. But for internships, yes, there are lots of internships, and Google always is, they're always hiring. So it's worth it to just put your hat in the ring, take some time to try to get one of those certifications like I mentioned, just try to make you a little bit more competitive. Don't see a lot of people in the market that have that certification. So for data analytics, that would be a certification in Looker. If they have them for Data Studio, but the two of them are good because Data Studio is free, Looker is paid. So a lot of people use Data Studio just for like initial concept design before they start paying for Looker. So the data analytics and then BigQuery. So there's like a data analytics specialization you can do that's all data analytics, like data engineering kind of stuff in Google Cloud Platform. But now in like BigQuery in and out. And then, like I said, try and make yourself look attractive. Try and just come up with a project on your own to do on your own time to develop a portfolio. I very rarely see people with portfolios, but when I do, it's an easy decision to hire them because I can actually go through and see, okay, show me your code. What did you do? What resources did you use? How successful was it? They can tell me like really rich story. And then I know, okay, you can pick up anything. Once you know, like, once you've built something with one of these services, skipping over to something else is no big deal. As opposed to that initial learning curve, it's like really tough to get on. So yeah, I think the internships are probably the more like niche focused, the better. And there's also like lots of subsidies to people who take care of it for health and so I recommend just getting on I think it's careers.google.com, and you can put in a search term and get emails whenever something matches that search term. So you don't have to go back and check all the time. So that's what I did, and I knew exactly what I was looking for. As soon as that email came in, I went and applied, and then the rest of the session was straight.
We have one more question in the chat and we're going to end on this question. What does the data-oriented future society look like? How will data AI contribute to our society? Or how do you think it'll contribute to our society?
One more time.
Sure. Sorry.
Data-oriented.
So what does the data analytics future look like? And how will data AI contribute to our society? How do you think it will contribute?
So probably the biggest areas of growth right now are the natural language understanding, and then the vision understanding. So that's where you see like big growth in trying to understand. So like that's where the computers have kind of hit their limitation, but because of computing power and just like advances in technology, those things like self-driving cars are becoming much more realistic. They won't just be self-driving cars. It could be anything really. Like we as humans think about how much you use your eyes and how much you use your mouth to get stuff done. That's what these applications are trying to help you with, and how debilitating it is if you're blind or vision impaired. You feel that, right? And so you can feel how useful it would be to have a technology just to help you, even if you aren't vision impaired, taking over a lot of those tasks. Because of the sheer amount of volume that we have to deal with now, things as simple as like, what articles are most worth my time to read today or this week? They're very hard to answer, right? You probably spend too much time figuring that out, or say, oh, I'm not gonna read anything, there's things in my mailbox, and I don't wanna figure out which one is most important to me. But that decision making. So anything that's, those two types of data sources, the language and then visions, really helps us to make decisions as humans. So that could be in like medical imaging. Is this X-ray, does it have cancer or not? Is this brain healthy? Does it have any signs of like deterioration? Is it going to be, is this like 40-year-old person going to experience dementia in 30 years? How can we help them? And then wearable technology for health. I see like a big growth area being health. You're a very sick society. Death rates are increasing, obesity, diabetes. These are all things that can be acted upon with wearable technology and just education for informing people about like giving their doctors information for them to actually help you to say like, your cholesterol has been increasing by 10% a year. If you continue like this, you'll be dead in 5 years. You can make a decision. Oh gosh, okay, well, now what do I do? Wearable technologies come into the picture. So yeah, the health industry, obviously like insurance companies are well incentivized to help lower your costs. Cost them a lot of money when you have to have heart surgery and mental health services and diabetes medication is very expensive for them, right? And their goal is to make a lot of profit. So it's in their interest to keep you healthy, right? It's in your best interest to keep you healthy, to live longer, be there for your family members. It's kind of there's no downside to this, basically. People will make money, you're gonna live longer. So I don't see why that won't just like skyrocket in
All right, thank you so much, Eden.
Yeah, just thank you again for always being willing to chat with students here. And thank you all for joining us today. Wish everyone a great evening. All right.